Welcome to my beautiful outer space layer. Thank you for watching this video. Hopefully this makes sense. And if you have any questions, we'll go over it tomorrow in class. So this is your lesson for today. We're going to be talking about inverse functions. And real briefly, just the definition of inverse functions. So you know, all you're doing in any function to get the inverse is you're going to switch the x and the y variables. So for instance, if you have like y equals, let's say, 2x minus 5, then the inverse function of that would be x equals to y minus 5. So just a quick visual so you can see graphically. Go ahead and graph this with me. Go to Desmos and type in y equals 2x minus 5. You can see that's just a linear equation. It's got a slope of 2, y-intercept of 5. Hopefully you remember those little facts about lines. But now if you want to get the inverse of that function, you are going to basically switch them. Now I'll show you how to solve for that later and do all that fancy stuff. But right now you can just say x equals 2y minus 5. And what you'll notice is these two graphs, they don't always intersect, but in this case they do. They intersect at the same point. Well, that'll always be true. Furthermore, if you were to maybe find that line of reflection, it would look like this. And that's simply the diagonal line y equals x. And I want you to think about why that is. My drawing's a little bit up. Just pause and think about why that is. Y equals x, x equals y. We essentially switched places with them. So what became y is now x and vice versa. So y equals x should make sense as to why they reflect over each other. Okay, just a quick visual of that. You can see here, let me clear this up. You can see that graph there. So now let's talk about just plugging in. You recognize this table before from a previous lesson. And I want to go through and kind of look at notation, all right? Because if you look over here, the notation for inverse has this little -1. It doesn't mean to raise it to the -1 power. That's just the notation we use. So if you see like g of 3, f of 10, that's just straight plug in for x, okay? If I see g of 3, well, then I want to go, where is x3? And I want to go to my g function, and that's simply going to be -2. Okay, when x is 3, the g function is -2. No work for that. Now, let's talk about. Well, let me use that as red. No, use a different color. Let's talk about when g inverse of 3. So this little -1 means inverse. I want to make that green. Come on. Don't fail me now. So my inverse function means that I want this 3 to actually be y, okay? But which y? Well, there's the fy's and there's the gy's. So this is g, so I want to go, well, where's gy of 3? And notice that it's right there, okay? Not this 3, not where x is 3, but where y is 3, at g. So now g inverse of 3, we say g inverse of 3, you're going to go over and you're going to report your x value, which is going to be 4. So that's the same way as saying g of 4 is 3. G inverse of 3 is 4, okay? So I want to know, what is x when y is 3? So pause the video so you can try something on your own and try C and D. You good? All right, f of 10, well, that's straight plug in for x is 10. So when x is 10, f is -1. Oops. We're in the wrong spot. When f is 10, x is -1, right there. Now, how about f inverse of -1? Well, let's see, when y is -1 for the f function, oh, we just got that. So we're just going backwards, and your x value is going to be 10. Is it starting to make sense? Okay, you just got to look for X and Y. Okay, let's put a couple things together here. So F inverse of 4, remember that's inverse. So if inverse means that this is the Y value, then let's go F inverse of 4, that's going to be -5. And then 3 times G of 6. Now that's just an X value there. So for G of 6, for 6, my G value is going to be -1. So that's a -1 there. Does that make sense? G of 6 is -1. So that's just going to be the Y value there. So when Y is -4 for the F, or excuse me, when Y is 4 for the F, my X value is -5. And then -3 times G of 6. So -5 minus 3 times -1 is going to be +3. That should be -2. Okay, pause and try some of these, see if you can put them together. All right, G inverse -1. So I'm going to go for the Y value at -1 for G, and that's going to give me 6. So the Y value at -1 for G is going to give me 6. Let me get rid of all these here so we're not confusing all my little previous calculations. So for Y value of -1, my X value is going to be 6. And then I have -2 times that. So it's going to be -12. Okay, hopefully you've tried G and H. We'll go through those. G inverse of 9. So let's see, 9 is my Y value. That's a Y value there. So my X value is going to be -1. So it's going to be 2 times that. And then F inverse of 0. So my Y value of 0 for F gives me an X value of -4. So we have -1, -4. And that's going to be 4 times that. So that should be your operation. So that's going to be -2 minus 16. That's -18. Of course, all these can be checked with a calculator if you need to. And then the last one is a little composition there. I'll put them together. So G inverse of 10. So I want to know when G for the Y is 10. My X value is going to be -5. So it's going to be -5 because that's a Y value there. And then I want to know, well, what is F of -5? Well, that's just straight. See, this is F, not F inverse. So F of -5 means I need to go to -5. And I need to give me the Y value. So that's an X value. So my Y value there is 4. So heavy stuff. All right, that is example 1. The next video will be example 2. Thank you for watching.